Hello, today's lesson is on 3.2 writing expressions. And the essential question is, how can you write an expression that represents an unknown quantity? And before we get started, what I want you to do in your graphing notebook is to write out a table where you have the operation words, addition, subtraction, multiplication, and division. And I want you to pause the video and I want you to think about the types of words that you see that mean those different operations. So I'm going to pull down the first one, for instance. If you see the phrase added to, that means you're going to be adding. If you see the words subtracted from, that means subtraction. So I want you to pause and think about how many words you can think of that mean all these different operations. And then I'm going to pull this down. So all of these, right, plus, sum of, more than. And when you see the sum of, these are kind of tricky words. The sum of usually means you're adding two things inside of parentheses, like this. And then the subtraction words are minus, difference, less than, decreased by, fewer than, take away. And for multiplication, we've got some words like product and twice. Of means times. I also want you to know that these don't always mean multiplication, but a lot of times if you see per or each, like if I go to the store and I buy apples that cost $2 per pound, I'm going to multiply the amount of pounds times the $2. And likewise on division, here's some division words. Okay, let's get that. Divided by, quotient of, and then I want you to know the divisor, right? If you have a divisor, you're dividing. That's the number on the outside of your division problem. And the dividend, that's the number that you're dividing into. And then also the per or each, because if I have something that costs $10 per 2 pounds, then I might need to divide. So with a per and each, it could be multiplication or division. It really depends on the context. Okay, next. So here's a few tips and tricks. When you see the word than, and when you see this subtracted from, I call these turnaround words. So it actually reverses the numbers. So this is my tips and tricks and turnaround. Can we write that? There we go. Turnaround words. So it doesn't really mean that everything gets turned around, but the order, it doesn't go in the order that it looks obvious. So if you see x more than 3, it doesn't mean it's x plus 3. Because you're saying more than 3, 3 is what you start with. So you would write it as 3 plus x. And when you see 7 less than y, that means you're starting with y and you're taking 7 away from it. So I call these turnaround words because you do change the order. And subtracted from is also another one of these terms. So when you say b is subtracted from 4, that means you start with 4 and you subtract b from it. So those are some examples of turnaround words. And then I wanted to just talk quickly about the difference between an expression and equation, which I think I mentioned in the last lesson. But an expression, right, it's kind of like a phrase. It's a part of a sentence. And it doesn't have an equal sign. But when you have an equation, an equation does have an equal sign. And so an equation, we often call them number sentences, right? Maybe in second and third grade, you call them number sentences. But I want you to think about the parts of an equation. If I'm just going to write this like 3 plus 7 equals 10, right? That's an equation. And what the equation is telling you is that the left side of the equal sign is equivalent to the right side. They don't have to look identical, but they are equivalent. All right, so I want you to open up your record and practice journal and go to page 63. And I want you to just start with some matching. And so you're going to pause this and try to match this on your own. And so I want you to first see that, right, these are all multiplication or division. And I see the product, I see quotient, I see 4 times, I see divided by, and I see twice. And those are the key words, and then I usually circle key numbers. Now I want you to know this is the product of a number. This is a variable, right? Whenever you see a number, it's a variable because I don't know what the actual number is. And so when I circle a number, I'm really circling what would probably be a variable. 4 times a number. So this is just what I do when I work on math problems. I underline the math terms and I circle all of the important numbers. So that's why it looks a little strange. Okay, so go ahead and pause yours and I'm going to do my matching. I'm going to go ahead and erase this. Okay, number, product of a number and 3. There's the product of a number and 3. And then the quotient of 3 and a number. And so quotient, right, the order does not change. It's 3 divided by the number. And 4 times a number goes here. A number divided by 3, that's the number n with the division symbol behind it. There we go. And then twice a number is when you multiply a number times 2. All right, so here's the first example I want you to write in your graphing notebook. It's example 1, and all we are doing is writing numerical expressions. We're not actually doing any math. I just want you to write the phrase as an expression, and you can see that the words that represent the operations are in red. And so go ahead and, well, you don't have to pause this because we're doing these together. So fewer than, remember, ding, 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 turnaround words. So I don't want to say 8 minus 21. I'm taking 8 away from 21. So this is 21 minus 8. And the product is multiplying, and it's 30 and 9. Now, I don't want you to use x for times. So I want you to use 30.9, or you can do 30 asterisk 9, or you can put one or both of the numbers in parentheses, because parentheses is an indication that you're supposed to multiply. Okay, so it's literally that easy to write numerical expressions. Next. Here's a few more examples. This is example 2 that I want you to write down, and we have an A, B, and C. And so I've got the key phrases more than, minus, and quotient. And so it's 14 more than. That means I'm adding 14 to the number x. So I do x plus 14. And then a number minus y. This does not change the order. It is just the way it looks. Y minus 75. And then the quotient of 3 and a number z, you could write it like this. You could write it like this. That's an expression. What I don't want you to do is I don't want you to write it like this, because that is long division, and that's technically not an expression. That's how you would actually do the division. Okay. So now we're going to get to the OYO. I want you to try these on your own. This is in the practice journal on page 62. So you can turn to that page and complete these and go ahead and pause it. And then I'm going to write in my answers. Now I'm going to be writing the literal translation. So 4 more than a number, and the number they want me to use. So these are the variables you're supposed to use. And so this is n plus 4, m minus 3, a number x plus 8, 10 less than a number is p minus 10, 7 units farther away is n plus 7, 8 minutes sooner, that means it's going back in time, t minus 8. 12 minutes later is w plus 12, and a number increased by 9 is you start with a number and you add 9 to it. Okay, now I'm going to point out a few things. Now you know if you take n plus 4, it's the same as 4 plus n. So I would accept this. It's just not a literal translation. And the same thing with the sum, right? 8 plus x, it does really mean the same thing, but I want you to not switch the order. And same thing with 7 units farther away and 12 minutes later. and a number increased by 9. But I want you to try to get in the habit of just translating it literally, even though we both know that if you change the order in an addition problem, you're still going to get the same answer. Okay. So now here's kind of a real life example where somebody could show you a map and they would tell you this, there's a whole bunch of words and it looks kind of complicated. I see a map, but I see a purple line and a red line. And I notice it says the length of Interstate 90. Now I'm not going to circle the 90 because that's not actually the map word. That's the number of the freeway. And it says Interstate 90 goes from the west coast to the east coast. So now I know that I'm going to draw an arrow to the red interstate highway, right? So this is I-90, and then it talks about how much bigger it is than Interstate 15. So I'm going to circle this number because that is an important number. And then it says it's this many number of miles more than 2 times the length of Interstate 15, which goes from Southern California to Montana, right? You guys live off of 15. It's not too far from your school. So this is I-15. So it helps me to sort of draw out pictures and I get an idea of what I'm trying to do. And yeah, this interstate freeway is much bigger. So it says, let M be the length of Interstate 15. So this is M miles, right? I don't know how many miles long it is, but it's M miles. And it says which expression, oh, well, it's a multiple choice in the book, but we're going to come up with an expression that we can use to represent the length of interstate of I-90. So I'm going back to this statement about I-90 is 153.5 miles more than 2 times this length. I don't know what this length is, but I know I'm calling it M. So if I take 2 times M and then I add 153.5 to that, that is an expression that I can use to find the length of Interstate 90. Now, obviously, I need to know what M is. I need to know the length of I-15, otherwise I can't actually do the math. But right now, that's how you set up the expression. Okay, so let's try an OYO. This is an OYO that has to do with game tokens. And I'm going to go right to this part that says your friend has 5. So here's my important number, 5, more than twice as many game tokens as your sister. And then it says, let T be the number of game tokens your sister has. So sometimes I just write a little note and I go like this. Sister has T tokens. Okay, don't know how many she has, but we're just going to say it's an unknown number of T. And now I go to friend. Friend has 5 more than twice the friends. So I look at, the sisters. I look at the sister, which is T. If I take 2T and then I add 5 to it, I will then know how many tokens the friend has. And that's it. I'm not telling you what T equals, so you can't actually do any math. What you're doing is you're setting up the expression so that when I do tell you what T equals, you can plug it in and you can tell me the number. Okay. If we have time in class, this was one more example that I was going to go over, so I'm going to show it here on the notes. Let's say that you're making this table and you're trying to predict, right? After you want to know. It's important when you plant trees in your yard that you know how tall they're going to get, because your neighbors might not be very happy if your tree blocks their view, or if they just don't want to look at the tree that you planted in your yard. So let's say that it says that when you plant your tree, it's 10 inches tall, and then each year it grows by 15 inches. And so notice that this table only goes up to 4 years, but we're trying to figure out what the height is after 9 years. And so I know when I first start and I plant this tree at time, we're just saying time equals 0, it is 10 inches tall. And then it's going to increase by 15 inches the next year, right? So when I add 15, I'm just going to go like this. I'm going to think about adding 15. So now the following year, it is 20 5 inches. And then I'm going to add another 15, and it's going to be 40 inches, and then another 15 is 55. I'm just doing some mental math, and then plus another 15, and I get up to 70. Okay, so I don't want to keep doing this, right, until I get all the way up to 9 years. So what I want to do is I want to start looking at the pattern, and I want to start writing the initial height plus the like how many inches it grows every year. So remember they gave us on this table, they said write an expression for the height after t years. So the idea is that in my first year, t equals 0 and the height is 10. The second year, I started out with 10, but then I added to it, right? I multiplied 1 times the 15. So it's, 1 times 15, which is really t times 15. So what if I did this? Could I do 1 times 15 as my pattern? The next year it was 10 plus 2 times 15, right? Because 2 times 15 is 30 plus 10 is 40. Okay, so now you're seeing a pattern that I have going here. Okay, 10 plus 4 times 15. And so this is one of those where when you see the word each, it means to multiply. So here's my pattern. It's always 10 plus the number of years times 15. So now I can write an expression, 10 plus, but instead of the 1, I'm going to use the variable t, because each time I substitute in the number for t. So, but here's what I like to do. Whenever I multiply a number, I could do this, t times 15. But whenever I multiply a number times a variable, it looks better, and most people will agree that the number goes before the variable. So now I've got this expression that says when I have the number of years, t is the number of years, all I have to do is plug in the number of years and I'll get how tall the tree is going to be. Okay, let's check it out right now. If I plugged in 4 times 15 is 60 plus 10 is 70. Yep, that matched. Okay, so now after 9 years, here's what I do. I plug in 9 for t, and I just plugged in t. When I put in a 9 in place of the t, and I do the math, that's going to tell me how big, how tall that tree will be after 9 years. So I don't know what 15 times 9 is, so I'm just going to go over here on the side and do the math. 9 times 5 is 45. 135. So 10 plus 135 is 145 inches. Now, if I want to convert that to feet, then I need to divide by 12, right? Because there's 12 inches in every foot. But this is how I used a table and noticed a pattern to write a really cool expression that can help me predict how tall this tree will be after 9 years. Okay. That's the end of the lesson.